Hi everyone, my name is Bar, and today I'm going to share with you how we build an agentic software engineering dev platform. So before I do, really briefly about myself, 10 years in software engineering, last 5 years working in Gen AI, where LLMs were basically, I'm not sure even in the oven, or only like a style gun in the vision realm was out there. In the last 2 years, I have the privilege to train a foundation model in the image domain. And today I have the most counterintuitive work in the world, where me and the team are come very happy to the office, but we work very hard to make ourselves very useless as developers. So I will start with say how we solve problems in the real world before I will deep dive on how we do it with AI. So basically, this should be a very familiar scenario for us all. This is an example of a meeting with a cross-functional team that enter a room to solve a specific problem in the company. So there are several expertise in the room. There is engineering, principal engineering, research, tech leads, front end, basically all came into one room, and they start working on a specific problem. And this problem might have something to do with research or planning. We need to think on what is the problem domain. Is it a clear solution? Should we investigate? Let's create a plan. Is there a specific algorithm that we should modify or implement, etc. And then, of course, there is a process where we start resolving the problem. And then during the resolvement, we might do another meeting. We might communicate in Slack. There is a different communication channel that each one of us like and help them to progress. Then finally, or mid development, we do the testing. And sometimes it's iterative. Sometimes we return back to the drawing board. Hopefully, but to get to the test where everything is just good and done and only fix some minor issues. And then, of course, the review part, again, it can happen during the development. It can be a final review after all the development is done. But basically, as we all know, a peer review to see that our work is solving the issue in the most clean way according to the organization standard. So this is a cycle, and again, all of us familiar with. So we'll try to mimic the same behavior here at Codo by providing tools for developer to do exactly that with AI, of course. So first, when we think about that, we have the agentic part. So the agentic part, we think of it to mimic how we engineer solve problem. Basically, we design the agents exactly like the domain experts in the company, and we design the agents specifically on how users in the organization, you can say the hats in the organization, are operating. And after we segment the agent or the roles in the company and start to think about them as agents, we look at them as a very domain specific. So it's a mixture of experts, meaning that each agent should do one thing very, very well. It doesn't mean that agent that is doing tests cannot write code. Basically, it's an LLM. You can ask him to write code, but he will probably be very bad at this task because it was very fine-tuned for the problem domain of writing tests. So after we develop, segment the agents and fine-tune them to do one task or domain of a task like testing very, very good, there is the communication. So in the previous example, we enter a room and communicate, and then we move to Slack to communicate. So the way that we communicate is MCPs. So I will not deep dive to how MCP work. A lot of before me already elaborate about that. But our agent, it's agent-to-agent world where each agent is exposed by an MCP endpoint. And of course, we need to share knowledge. So each one of the agent can log his work, and then the other agents can review the log and continue the work or rely on the previous part that the agent has done. So this is a very, very high level of how we look at the problem domain. So now let's do one level deeper. So today we have three main out-of-the-box agents. So Codo Aware, as we call it, is the context king, as we call it internally. Basically, it's a principal engineer, architect, all the context is there. You know how to travel, you know how to collect and understand the organization data across the board horizontally, and it's doing a very deep analysis of problems. CodeGen is the execution agent, so it came in two variations, ID extension and CLI tools. Basically, he can take a problem and start executing it, run the tests, start iterating, modify the files, touch every bits and bytes in the code, and start doing the coding job. And then CodeEmerge is the agent that is doing the review. You can add the review during the development. You can add the review after the final development, and all the commits are gathered in a pull request. But it basically done a review and make sure that everything works correctly. And again, we have the shared memory layer, where you can imagine, for example, CodeAware did some planning, and it's summarize a plan. He will save it in the shared memory. CodeGen will start generating the code. Then something will be off. The test failed, and he will go back to the principal engineer and said, okay, let's rethink the issue. So how we know how we did so far, we will access the shared memory and start engaging with ourselves until a specific point. And then once both are finished, we will ask the reviewer to review. So it's like a process where they can ping pong back and forward to solve very complex issue. And again, we're talking about enterprise scale. It's not my side project that I created that I need vibe coding. It's much tougher problems. So we didn't start in the most tough problem. We did start with vibe coding level problems. So the obvious way to start is to have like an LLM and prompt it. And this is a very naive approach, and it solves problems. I can't say that it doesn't work. And then the next evolution, when we think about the problem, was doing the classic RAG. So you encode the entire code base, you put it in a HNSW space, some vector representation, and each time a user query, you fetch the correct context, and it gives another push to the LLM in order to solve the problems. But then we hit a wall when enterprise scale, and we need to generalize the problem, because each enterprise have its own set of problems, its own flows, its own challenges. So working with just the RAG approach, let's say, was failing catastrophically. So then we moved to the whole concept of the agent, meaning that each agent is very, as I mentioned before, very good at what it does. And when we look at the aware agent, which is specifically the one that I will go into deep dive today, we understand that in order to do deep research, it's not only a RAG thing. We need to go deeper and wider. So this is why we moved to agentic world, also in the deep research and aware capabilities. So today our system looks exactly like that. And again, we call it aware, which is basically the principal engineer that look widely on the organization and know how to design deeply and try to create plans for the later agent to execute and review. So it's all start on the organization data. You have raw data everywhere. There is docs, there is logs, there is errors, there is, of course, the code. There is a lot of raw data existing in the organization. So first thing that we do, we have an agent that is parsing the data. So for coding, we have, if you're familiar with the tree sitters, to chunk the code and split it into smaller chunks to later embed. And for other aspects, we use maybe an LLM that will go to the files and create summarization of the files. There is a lot of small stuff to be done in a lot of data before we proceed. But mainly this process is taking the huge amount of data and splitting it down to a smaller data unit size for later processing. And next, after we have all of this data chunked in a smart way, again, it's an agentic way, we use embedding models. We have two different type of models, embedding models. We have the, let's say, OpenAI ones and the open ones that everybody can use. We use it for the majority part of the data, but for coding specific, because this is our bread and butter, we fine-tuned a code embedding model ourselves. So we have 1 billion and 7 billion parameters models. And these models are specifically tailored for code. So once they got from the previous step a chunk of code that you need to embed to later on do your analysis, they are very good at that specific task. If you have a documentation or PDF file which have a lot of architecture data or stuff like that, I will not use that these type of models because, again, only for code-related stuff, we find that it's boosting our performance. And once we did these two steps, now it's the time to start model the data. So as I mentioned, we start with a simple RAG, so a similarity search, HNSW. It's the most common way to store the data. But later we found that a single context provider is not enough. Sometimes the problem can be a user just trying to list something exist in the context. And in this case, I will just go to the database and just do order by repositories and give them the results. We don't need chunks. We don't need even an LLM, only an LLM maybe for the reasoning to understand to do it. But afterward, we just need a query with a group by of the queries. So not every question or challenge or user intent is not all of them born the same. And we understand that for each complexity of question, you need a different hop or maybe multi-hops. Maybe we will start with an LSP approach to order the call stack for a code, and then go to the similarity search and fetch data for each data point, for each node in the graph. Maybe you have a knowledge graph, which I will not use for code modeling because code is not a graph approach, but for the documentation of the organization, knowledge graph might be a better representation. And when you need to correlate the current architectural stack to the coding implementation, you might find that the agent will do a better job to fetch context from these two approaches and merge them together for a more holistic answer. So we found that adding more providers really helps when moving to agentic to pinpoint the correct data retrievals. And then, of course, we move the agentic. So the agentic, we look at it as maybe the front end. So each agent that we have, it's a system, right? I mentioned now all the steps, and eventually there is an agent which is the let's say the front end that the user is engaging with. But behind that, each one of our agent, it's a whole system. And the agent task, we have two agents that do different tasks. One we call deep ask, and one we call deep research. And these agents have tools. So just an example of a couple of the tools that I throw here. So one of them can be maybe read the full file. So sometimes we chunk data for a fast retrieval, but sometimes I need the full file. Another one can be doing a query to the database to fetch something. Another one will be the classic RAG for calling the HNSW and get chunks of relevant data, and so on and so on. There is a lot of tools, and each of one of them or a group of them together can be valuable for a specific user query to serve the intent. And again, we are talking about here about the specific research agent that is called Aware. And of course, it have its own local memory, in opposed to the previous slide that I showed that agents are also talking together in a memory, but also this specific agent have its own memory in the stack. So overall, for evaluation, this is a benchmark that we plan to publish open source very soon. You can see here, there is the ground truth, of course, and you have the x-axis, which is the how fast the response received, and on the y-axis is how good the answer was against a ground truth. So you have here several components, no context at all. It's just asking an LLM a question about a coding challenge in the organization, and you can see that according to the ground truth, he doesn't have the context, so for sure he will not be able to answer it correctly. And then you have the existing Codo RAG, which is a component that is live today and users are using. So it's fast, but it's not the most accurate one. But again, for vibe coding challenges, it works very good. But this specific benchmark is for the enterprise scale, where the answer doesn't exist in one file or two files, and sometimes exists in multiple repositories. So it's much harder challenges for the system. And then you have three very popular tools, for my opinion: Claude CLI, Codex CLI, and also Codo have its own CLI. So they think a bit more, approximately like 1 minute of thinking, and they provide somewhat a good answer like the RAG is providing. And then you have the use cases for the deep ask, for the research agent use cases, where again, it thinks very, very long time in opposed to the other method, but the answers are much more refined than the other methods. So it's maybe not a use case for the vibe coding when you connect it to vibe coding tools like Cursor or stuff like that. But for the outside of the ID workloads where you put a prompt and you like to wake up in the morning and see the task completed, so you can ask this agent to research and then give the plan to another execution agent and then do the review. And then you wake up in the morning, give him to operate this flow for like 5-6 tasks, and then make sure that 1, 2, maybe 3 passed the test, or maybe you need to fine tune something and proceed. But this is the use case mainly for the deep research tasks. It's not a real-time thing, but again, it provides much better results than doing it with a RAG or a non-agentic workloads. So I mentioned a flow. So here is a possible flow of how it can operate. So the user might have some bug. Let's say the company. It's a real use case from a company that we work with. They have they implemented their own auth, even though it's a solved problem. They didn't want to use out of the box SaaS solution. They developed their own auth, and each time user added a new provider, it was creating issues down the road. And in order to solve it, they need to do an architecture change. It's not just let's fix the current issue that adding the provider was creating. Let's just do a refactoring of the system to make it more robust to adding new providers. So in this kind of flow, they might go to their coding interface, maybe a CLI, maybe a UI that they're doing the code with. And then they start the flow where, first of all, they do the planning, and then they do the resolve, and then they do the testing, and then they do the review. So this is an ordinal way to solve the problem. But in the real world, you will let maybe the agent to do the reasoning and say, okay, I need to do the research. It's not a simple prompt. The intent here is very intense. So we need to first do a couple of research tasks and then do the review and make sure that this plan is according to the organization guideline, and then do the coding and then do the testing. So it can be a lot of possible workflow to get the final results. So it's not one deterministic workflow that I can say that work for every company, for any use case. There is a lot of workflow that are possible. So in the end, this is my final slide, we learned that building an agent that do one thing good and treating it as a system. It's not just an agent that we give him tools. It's a system. There is a lot more behind the scenes that powers the agent. Is one task. This is the first tier. First of all, you build a very good agent. Then you need to communicate between this agent and other agent. So of course we use MCP, which is the common protocol for doing that. But the agent need to be well defined. The description of the agent must be very, very well defined, because later in workflow, it becomes critical for the other agent to do the decision making on how to call and when to call and how to bind each one of the agent all together. And of course, heavy benchmarking. So we do a lot of benchmarking for each agent by himself. We don't test the communication between them, which is it's a different thing that the industry is lacking right now, like a cross benchmark between agent. But we do test each one independently on specific tasks to prove that it managed to solve these tasks. And then the orchestration and workflows. So mainly when we build our stuff, we build, again, specific agent that doing one thing well. And a lot of the time, the builders, the customer that we work with are doing the orchestration and workflows, because we as a company cannot support all the use cases and all the workflows for any organization or any use case. So sometimes the binding of the agents is a second tier issue. So we are heavily focused on doing single agent that do one thing good. We do have out-of-the-box workflows, but we mainly see that customers taking this and build the workflows themselves. And then last thing is user feedback. So we have like an active Discord community and some things open source. So I know that I didn't show today open source because for the research agent, we are still working on that. So hopefully maybe next time I will be able to share about that. But we do have other stuff open source like PR agents and stuff like that that you can see in our sites. But it's very important to engage with the community. A lot of the good feedbacks and the roadmap ahead is based specifically on that. So it's very important. That's it. Thank you.